Hello everyone, my name is Mohamad Ghribi and this is my presentation. First, I will start with system overview. The face recognition process has four interrelated phases or steps. The first one is image capturing. It's the first step in the face recognition process. It is the capturing of a face image. This can be done using a still picture or a video camera. Second is face detection. In this step, the system has to decide which pixels in the image is part of the face and which is not. The next step is normalization. After the face has been detected, after it has been separated from its background, the face has to be normalized. This means that the image must be standardized in terms of size, pose, illumination, and etc. To normalize a proper image, the face landmarks must be located accurately. Using these landmarks, the normalization algorithm can remodel the image for slight variations. Recognition can only succeed if the proper image and the gallery images are the same in terms of pose orientation, rotation, scale, and size. The last step is face recognition. In the last phase, the biometric template of the face image is compared with the biometric template of each face in the database. We recognize the face when we get a match between two templates. Moving on to system characteristics. And the first characteristic of my system is fast face processing. My biometric face recognition system will perform a fast and an accurate detection of a face in a live video stream or from a still image. Second characteristic is live face detection. The customary face identification system might be cheated easily by placing a photo of another individual in front of a camera. My face recognition system has the ability to prevent this type of security hack by determining whether a face in a video stream belongs to a real human or just a normal face picture. Another characteristic is face image quality determination. A quality threshold might be used during the face enrollment to make sure that only the best quality face template will be stored into the database. Tolerance to face posture. My face recognition system has a certain tolerance to face posture, which assures that the face enrollment is convenience. Moving on to implementation details. First, I installed PyCharm IDE and downloaded OpenCV library by the package manager system. The benefit of the implementation with that library is that it provides pre-trained face detection and recognition models, and it provides an interface to train a model on my own dataset. After getting that OpenCV library, I imported another library called Face Recognition to recognize and manipulate faces. The next library called OS library, which provides functions for interacting with the operating system. And our last library is NumPy, which is useful in working with arrays. These are the libraries that I used to implement my project. I also used some methods and functions, starting off with getEncoded faces. What that method does is that it asks the system to look in a special folder where faces exist and encodes all those faces that can be found. Another method was known image encoded. It simply gets whatever the image name is given and encodes that into a format that my machine learning model can read. Next, I have a method called classifyFace. It takes the name of an image that will be applied to face recognition system, and then it goes and brings up a box and do the detection and show you the identifier of the face so you can see which face in that image. The system will get all the encoded faces and then it will sum all those faces into a list. Then the system will read the face that is given as a test.jpg and find all the locations of the faces in that image by simply pasting img to my function. Now we move to comparison step where we compare all those faces in the images and see if any of them are the same. And if they are the same, all we do is we draw that little box and we write the name of the individual face on that little box. Otherwise, we write unknown, and that is simply how I implemented my project. And here I explain the code from the beginning. First, I imported all essential libraries for my project, and as we know, we need a method to transfer faces into coding form. And that's what this method does. It will go to the faces folder to transfer every face to convert it to a coding form. What I mean by a coding form is to make them compatible with the compiler. In these lines, I am getting the dictionary of Python. We use it to store images and data values. Some of them are faces, some of them are names. So that is how we load Python dictionary. In this folder, I have some files. As we can see, they are called test1, 2, 3, 4. And here we can see this method. This method encodes all these given faces. Why do we do that? We do it so the compiler can deal with it, can deal with these files, can deal with these faces and these informations that exist. Here we have a method that will search for multiple faces in case they exist. Here I have two lists, one for faces and one for names. These lines will check if there is a match between the two faces. It will check if the face is stored before. If it's stored before and it matches a face from the database, so it will give a match and recognize the face. We have this method. This method will take the lowest distance between the two faces, because the face with the lowest distance is the closest one to match the image face from the database. Now this line will draw a box around the face so it can show that it recognizes the face. This also will draw a label with the name of the person below it, and this line will display the resulting image. So that was the code representation, and now let's run the project and test it to see how it works. I'm gonna test the project with each image I have, just to make sure it works properly. And as we can see, all images worked with no problems. Thank you for watching and have a nice day.